One of the greatest puzzles in the history of science is the structure of the atom. Let's put the pieces together and figure out how an atom works. If we look at the evidence that came from experiments, people have learned that atoms have small negatively charged parts or particles called electrons. Atoms also have positively charged parts, which are concentrated in an area called the nucleus. Let's see how these pieces work together. If we have a positively charged nucleus and a negatively charged electron, we can use our understanding of electrical interactions to figure out how these two objects will affect each other. Since they have opposite charges, these two objects will attract. Now, we also learned that the positively charged nucleus is the heavy part. So we will assume that it doesn't move. It stays in place. So if these two particles are attracting each other, and this one stays in place, the electron is going to experience a pull towards the positively charged nucleus. This leads to a really important question. Why don't all the electrons simply crash into the nucleus and stay there? What's the solution to this part of the puzzle? The solution is speed. The electron here is actually moving very fast. So let's suppose it is moving quickly in this direction here, but experiences a pull towards the nucleus. What's going to happen? Well, we get a combination of two effects. One is the movement that it has in this direction, and another is the pull that it has towards the nucleus. So if you can imagine watching this electron, and then a moment in time later, where would we find it? We wouldn't find it over here. We wouldn't find it over here. So we're going to find it somewhere in between, over here. And now the pull is a little different. The pull is pointing in this direction. And because of the pull, it's no longer moving this way, it's now moving in this direction. And so we can ask ourselves the question again, a moment later, where are we likely to find this electron? Not over here, not over here, but somewhere in between. Let's say around here. We can repeat this thinking process and follow the path of the electron around the nucleus of the atom. So if we trace the path of the electron around the nucleus, we notice that it forms roughly a circle, and we call this an orbit. So in our mind, we can visualize this just like the moon orbiting around the Earth, following a roughly circular path. This is one model for understanding the structure of the atom. This is how scientists came up with the idea of electrons orbiting the nucleus of the atom. As long as the electron is moving fast around the circle like this, the electron is never pulled directly towards the center. Instead, it's pulled into this curving circular path around the nucleus.